So we have drew a number of conclusions from this, and I won't go through all of them, but this was obviously something that could have been prevented because they were making decisions on an individual step-by-step basis rather than in a systems approach. If they began to kind of put these things together, they could have made much smarter decisions going forward. Part of the problem is that they were behind schedule. It was costing lots of money, and they wanted to finish up, tremendous pressure. So they began to rationalize all of those things. Also, compared to other companies which work in deep water in the Gulf of Mexico, they had very, very poor communication with the beach, as they call it, people on shore. If you go to Shell in New Orleans, they've got 24/7 guys watching over the shoulder of people on the drilling rigs. All the meters, gauges, videos are right there. BP has a facility where they meet in it for 15 minutes a day. So they were really poorly equipped. But we felt on the result of that this is really a systemic failure. That because of the other contractors, the Transocean, as well as Halliburton, which is the cementing job. You might remember that former Vice President Dick Cheney was CEO of Halliburton at one stage before he went back into government. That it was a systemic problem, and in addition to that, there was really a lack of governmental oversight of this whole process. The reason this process was under-resourced and the capacity of the people doing the oversight was they were outgunned, and they just weren't up to it, was because the industry fought stop them getting resources. They didn't want regulation. So this is the result of it. And furthermore, not only BP, but Shell, Texaco, Exxon, any of those companies, none of them had the capacity to shut this well down, to contain the blowout once it occurred. So that's a systemic problem. We've caught a lot of criticism by the industry because they feel we're painting them with the same brush as BP. Make clear that some companies are much more exemplary than others, but they all have these kinds of problems. The basic challenge we have, as I mentioned, I actually lived, before I moved to Maryland 21 years ago, I was living in Louisiana, working there. And this graph here really brought it home. I left in 1990. This is the oil production from the U.S. Gulf of Mexico. And these are from the light blue here is from wells in water depths shallower than 300 meters, that is shelf or upper slope. And the darker area here is water depths deeper than that, and then the ultra is deeper than 1,500 meters. So we can see in that period of time we went only 3% of the oil being produced in the Gulf was from deep water. Now it's 85%. So this was a major expansion, technological marvel really, but without proper attention to the risk issues going forward. You can see now, and then this means as you leave the shelf, not only you have to drill from floating vessels, but you have to produce from floating vessels. So in the long term, you've got production facilities that are either floating with all sorts of elaborate pipe work on the bottom. The other thing which is quite remarkable, this is the amount of money that the agency in the Department of the Interior that's responsible for this is spent on environmental studies over the years. This was a period when there was big controversy when they were trying to expand offshore drilling to other parts of the country. So there were throwing money at the problem. This is when I left in 1990, and you can see as we moved in deep water, in this riskier situation, we de-invested in science. A serious lesson that we need to correct. So a number of things you've probably heard about played out in the press and then in the scientific journals. There was a great degree of controversy about where's the oil. You know, there were 5 million barrels of oil. So that's what do the math, how many liters it is. It's a lot of oil that was released because it lasted for so long. We first thought the first estimates were that the flow rate was about 1,000 barrels, and they kind of upped it to 5,000 barrels. And now in retrospect, even early on, our best estimate is that it was flowing at 50,000 barrels of oil, 60,000 barrels of oil. And then as the reservoir depleted, went down to about 50,000 barrels of oil. So a tremendous amount of oil. So our friends at the National Climate Center for Atmospheric Research of course, rushed out and did these models which showed on ocean circulation that said, aha, this oil can come around and go all the way to Denmark, right? Just about. But this was without, I mean, this was nuts because it had it brought in nothing about what happens to the oil, evaporation, biodegradation, all those other things. And so I had, when this was going on, I had my governor demanding that I go with him to Ocean City, our resort, during the summer, and assure through the press that this oil wasn't going to come up and foul our beaches. So this is science not very carefully done, because it sent the wrong message out to people. What happened is that we got kind of lucky, is that if you might know, there's a loop current, the current that loops around, kind of comes up through Cuba and shoots around, overshoots, flows around. And at the time this spill was taking place, it spun off a gyre. So that kept it without, detached from the southward flowing loop current. Kept it pretty much in the Gulf of Mexico. This is Jane Lipchenko, who's now our administrator, very famous marine ecologist, who happens to be now our administrator of NOAA, National Ocean Atmospheric Association. She got thrown in the middle of this and got torn apart because she had to make, sing the government's message. This was a case when they were in August, trying to explain where the oil went. And the purpose was to see how much oil might still be out that they could deal with. It wasn't a mass balance per se, but it got spun. The president's environmental advisor, Carol Browner, said, this means that 75% of the oil is gone. Jumped on by the scientific community, press, you can't say that, you can't say that. The result is that a lot of these things is that the public lost confidence. They weren't getting the flow rate, this issue. They didn't know who to believe as a result of it. Well, and in reality, the oil now that's remaining is a very small amount of that oil remains. It's in one of three places. One is that's stranded in some of the marshes in the area that they can't go in and clean up because they'll do more damage to the marsh if they trying to clean it up. There's some tar balls in the shallow subtidal along sandy beaches where the sand kind of weighted the oil down. And as we'll see here, there's also oil in the deep sediments near the well site. We don't know exactly how much is yet remaining, but a very interesting thing was observed, and we should have known about this in advance. This is the controversies over this deep water plume. Imagine this oil and gas is shooting out of this wellhead, and just the physical nature of the mixing. Imagine the natural gas is expanding coming out of this, the turbulent mixing. So it creates what I tell local, lay people is like a sneeze, droplets of oil, as well as a tremendous increase in concentration of dissolved hydrocarbons, including gaseous hydrocarbons, methane in particular. So we then actually, first papers that came out actually in July of last year by a group at Woods Hole showed this deep water plume kind of migrating through the geography of the area. And it was basically constrained between 1,000 and 1,400 meters. So that found its depth and it continued to travel. A number of investigators have been looking at what happened in this deep water plume. There's actually some controversies about this that I'll mention. This is a paper that was published early this year, which showed this is a vertical integrated DO anomaly. As this gas and oil comes out of the well, it's microbially degraded. It draws down the oxygen. So looking at profile that you'd expect, and then looking at this profile, this is the anomaly that you have. And this was mapped here in the late, or in October, let's put it that way, some weeks after the spill stopped. And these authors basically concluded, having earlier measured methane concentrations related to this input, and now seeing this DO anomaly and no methane, that this was all, methane had all been consumed, it had all been biodegraded. And this is also near this deep water plume. These are some of the rocky outcroppings. These are deep water corals that were covered by slime, basically, a microbial bacterial bloom that kind of then fell out on the seabed, causing, you can't see this very well, but a layer of small droplets of oil in this bioceston, if you will, as well as smothering these deep water corals. This is a concern because these corals, although limited in extent, are presumably very old. So the controversies continue. This is just from 2 weeks ago, I guess, in Science. This is the paper I first told you about. It's not working right now. Kessler et al. And then Mandy Joy has responded, no, you're wrong because the can't have gone away. You sampled in the wrong place, da 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 da. And then Kessler saying, we refute the criticisms which are incorrect, internally contradictory, and overall do not disprove. So there's a great scientific debate. It's the way that science works. From my perspective, having served on this commission, thinking of this big picture, I'm saying, so what? You know, this stuff is gone for all practical purposes. What? I'm back. And whether it's gone in 2 months or 4 months or whatever, does it matter in terms of how we deal with the challenge going on? So it just kind of gives you a bigger picture and bigger perception. A lot of controversy over the use of dispersants, chemical dispersants. These are surfactants, which are meant to kind of break down the oil into little droplets, so make them more readily degradable and get them off the surface and into the water column. A lot of the surface application was probably fairly ineffective, but they actually did something which never been done before. They injected dispersants at the wellhead into the plume coming out to try to break that so less of it reached the surface. They did that, interestingly. The big driver for it was concern about worker safety at the well because they were having serious problems. Camilli, the author of one of the first paper I showed you from Woods Hole, tells us a story about he was waiting to go and take samples out at sea with all these vessels around the wellhead, and the Coast Guard officer came up to him and said, "Sir, you've been drinking?" Because his voice was slurred. He had benzene toxicity as a result of just breathing this. So, and they're worried about explosions and that sort of thing. So, make a long story short, actually dispersants probably helped, kept the oil away from the surface and from the coastal areas and from birds and sea turtles and things of that sort.